In this lesson, we'll be looking at something called a slope field. This is an example of a slope field. And what it is, we start with a differential equation. Remember, that was an equation written as dy dx is equal to. So it is telling us a derivative of a function. So what the slope field does for us is it tells us the slope at different places. So just by plugging in x and y values to our differential equation, we'll be able at those points to know the slope of our original function. Now what we can do with that then is say we know a point over here, well it's going to have a slope like this here, and we just kind of follow the field to see about what direction. So I see that here I'm kind of smoothing out. I need to come to a slope of 0. I don't really have anything beyond this. Maybe working backwards I need to see that, okay, I have a slope of 0 here. Oh, but then it goes negative, so I need to have a slope of -1. But then it's going to curve up, have a slope of 0 again. And so just following through here and trying to follow those little lines that have been made, I get an idea of what my function would be. And if I chose a different point to start, my function might look just a little bit different depending on where I go. We always want to just follow in between these lines, trying not to go, never crossing them, but trying to stay between them or else running alongside of them. So to construct a slope field, we might start with an equation like this. And this is the same one that we had in our last lesson, except we did it a little bit different. We found it by taking an antiderivative. Instead, what we're going to do this time is plug in different values for x. Notice this one's completely in terms of x. Plug in different values for x here. I'm always going to get a 1 here, 0, -1, a 0, 1, 0, -1, 0, and 1, which tells me that anywhere that I have this -2 pi, my x has to be equal to 1. So it's good here, but it's also good here, and here, and here, and here, and here, and here. And even if I drew between those, it would be the same slope. Since this is only in terms of x, that x value will always be the same. The next one is a slope of 0. So anywhere where we have -3 pi over 2, we have a slope of 0. So we'll just draw a little hash mark there, not too long. And then the next one, -1, which is going to go like this. The next one, 0. The next one would be 1 when x is 0. When x is pi over 2, we're always going to get 0. When x is pi, we'll always get -1, 0 again. So these do take a little while to put together when you're doing them by hand. Most of the ones we do will not have this many points on them. And so if I gave you an initial point, just like we did on the last page, if I knew where we were starting, I would know how to follow that to get a general shape here. And notice that this is basically following the sine function, sine curve, sine of x, plus a constant. Also notice that I could move that curve up or down. It would still follow that. So what we just made was a slope field. And when we're doing this in terms of x, then our function is just going to move up or down. Like this red curve would just move up or down and be our sine of x plus a constant. But sometimes it's helpful because if our differential equation had x's and y's in it, then it's going to change depending on where we are. And this will even work for equations that are not function, and it's going to be based on the derivative. It's going to help us see the shape of the graph. Okay, so for example, this one here, it's not necessarily a function because we have this in terms of x and y. So if I want to find a slope field for this, I have to look at every point. So if I start at 0, 0, I'm just going to get a slope of 0. If I move over then when x is 1, if I keep y equal to 0, it would be 0 plus 1. 0 plus 2 is going to get a little bit steeper, and 0 plus 3 it's going to get a little bit steeper. Now one thing to look out for on the AP test, what they're looking for with their slopes is that they're going to be looking for a 0 slope. They'll be looking for a positive or negative slope, so going up or down correctly. You should know when the slope is 1 or -1. It should be pretty close to 1 or -1. But then other than that, if it's a fraction slope, it should be less steep, or if it's something like 2 or 3, it should be more steep. Okay, so these don't have to be perfect, but we should try to get them about right. Mostly we want to look for making sure we have positive negatives and ones go in the right direction. So I've just made these a little bit steeper. Now as I move back, y is still 0, so x is -1, so my graph would look like that. -2, a little bit steeper. 3, a little bit steeper. I could also go up here when y is equal to 0, so 0 plus 1, 0 plus 2, or going down?
-1, -2. 1 plus 1 is going to give me 2. 1 plus 2 is going to give me 3. Over here we would have 1 minus 1, which is 0, and 1 minus 2, which would be -1. Over here, if x is 2, y is 1, that will give me a slope of 3. 2 plus 2 is going to give me 4. So it's going to get steeper. 2 and -1 will give me a slope of 1. 2 and -2 are going to give me a slope of 0.
So we would just keep going around filling these values in using x plus y, which will come out looking about like this. Sometimes they'll ask us to sketch a particular solution. So they're saying if we're starting at the point 2, 0, so we find that on our graph, 2, 0, sketch what that curve would look like. Now following that curve, I'm going up in this direction. I try to stay between the slope hash marks that I'm given. I want to try to stay between them as much as possible. I never want to cross over them. We want to kind of try to follow. So going between these two here, I want a slope that somewhere evens out between them. And then coming up, notice right here we always had a slope of -1 right here, because this is where we would have x plus y always giving us -1, which means we actually have an asymptote line there. So as we come up close to that, since that's a straight line, that's going to be an asymptote line for us, so we don't actually want to cross that. And so our curve would look something like that. Okay, the next problem will be matching slope fields with differential equations. When we're matching slope fields, the best way to do it is use elimination. Start with some easy things that we can look at first and see if we can eliminate stuff rather than calculating all of these points that we have. Maybe one way that we could start is just by looking at 0, 0. Now in that one, this one, it doesn't really help us because we can't really tell what's happening at the point 0, 0. Usually the second one's the best one. Look at when x equals 0 and y equals 0, or really we're looking at the x and y axes. Okay, so for the first one here, notice that on my y-axis, that would be when x is equal to 0. So when x is equal to 0 on this one, our slope is also 0. When we're looking at the y-axis, when y is equal to 0, our slope is always vertical or undefined. Now, the fact that we're getting undefined slope tells us that we're in a denominator, which is probably here at 3 or 4. So looking at this one, when x is 0, we get a slope of 0. Now that could either be 2 or 3, but since we also have that undefined when y is 0, that would have to be 3 right here. Now looking at this one, notice that it is changing here along the x and y axis. So I'm going to skip this one and come back to it another way. Now notice on this one, when x is 0, it's undefined, which means this would be the one where x is on the bottom. Since we have a vertical here, whenever x is 0, our slope is undefined. This one has to be number 4. Okay, the next one, D. When x is 0, our slope is 0. When y is 0, notice all these are curving, they're becoming horizontal. Again, m is equal to 0. Where does that happen? Well, only here where we're multiplying those two. And for the next one, x minus y, we could just say, well, that's the one that's left over. Another thing that we could look at for these is in the quadrants, maybe looking where they're positive or negative. So if I'm in the first quadrant here, positive, positive, like for this one here, number 2, notice I'm always going to be positive there. I'm negative here, I'm positive again, negative here. So that would also help me fit with all of these. And actually all 3 of those are probably going to follow the same pattern in terms of whether our slope, whether it's going up or down. For this one, we might also look at specific values. If we get stuck, notice along this line right here, looks like we have, it's when x is equal to 1, y equals 0, we'll get a slope of 1 there.